Hello and welcome to this Ignite session on enterprise integration, success stories, and best practices. I'm Derek Lee from the Azure Logic Apps team, and joining me today in this session, I have Beck, Divya, and Parth. They will help me to cover various aspects of our integration offering, deep dive into new features, patterns, and best practices. So let's get started. First, let's talk about what is integration, why is it important, and what we have to offer from Microsoft and from Azure. Integration for companies large or small, it's often not a choice, but by necessity. Various systems the company relies on, ERP, CRM, supply chain, identity, HR, etc., on a daily basis needs to talk to each other. Companies in their journey of cloud and digital transformation won't be able to finish everything in one go, but also can't leave systems that remain on premises behind without integration. New and emerging workloads and scenarios often require fast-to-market development, especially in today's fast-changing landscape. And our comprehensive offering within Azure Integration Services by Azure and in partnership with Power Platform and beyond makes us uniquely fit to solve these challenges. So let's double-click into Azure Integration Services. It is made up of a collection of services including Logic Apps, API management, and Service Bus at the core, along with functions, Event Grid, and Data Factory. Collectively, they cover workflow automation and orchestration, API management and monitoring, enterprise-grade messaging and eventing, serverless compute, and ETL workload. We're recognized as the leader in Gartner's Magic Quadrant on Enterprise Integration Platform as a Service 5 years in a row, and most recently in the Forrester Wave report as well. If you are new to Azure Integration Services, I want to spend a few minutes to give you a quick introduction of Logic Apps and API Management, the two services of our focus today. Logic App is a general-purpose workflow engine for building fast integration, orchestration, and automation with its intuitive visual designer. Out-of-box connectivity are provided for more than 400 services within Azure, such as functions, Service Bus, machine learning, container instance, by Microsoft such as Office, Dynamic, and third-party services such as SAP, Salesforce, and ServiceNow. The runtime is highly resilient, designed for and trusted by our customers to run mission-critical workloads. You can develop workflow in Azure Portal, on Visual Studio, or on VS Code from Windows, Mac, or Linux. The runtime is also portable, so you can run it locally during development and debugging, on Azure Fully Managed, or on Azure Arc. And for API management, it provides matured, full lifecycle management for your APIs. It helps you to abstract, secure, observe, and make APIs discoverable in minutes. Just like Logic Apps, which works both on the cloud as well as with on-prem systems, API management is also the one solution that you need for all your APIs across clouds and on-premises. It is dependable, secure, scalable, and performant. Now, rather than me telling you how awesome these services are, why don't we hear directly from the customer? It is my pleasure to have Dylan from ASOS joining me today to tell their story.
Hi, I'm Dylan Morley. I'm one of the principal software engineers at ASOS. If you're not familiar with who we are, ASOS is an online retailer for fashion-loving 20-somethings. We have web and app experiences serving 200 countries, available in 10 languages and supporting 24.9 million customers. In the last financial year, ASOS processed just over 80 million orders, just to give you a sense of the scale we operate at. We've been working with Logic Apps Standard for approximately 8 months now, when we made a technology choice for building a new integration with a third party. First, let's consider how ASOS engineering is organized to deliver software. We follow what we call a platform model, A platform is aligned with a particular business capability and may look after one or many microservices within that area. The teams are responsible for everything required to build and run that capability and are therefore interested in things such as the compute, data stores, CI/CD pipelines, and monitoring. However, what we often find is that since data has been decomposed into multiple discrete applications, in order to realize certain business requirements, services need to integrate with each other and share data. We also find ourselves integrating with third parties, and whatever data we produce needs to be ingested into our data lake, allowing us to form coherent views over all these systems. And this is where we've chosen to use Logic Apps within ASOS, allowing us to bridge the gap between systems with a low code and low barrier to entry solution that aligns with our platform model and allows teams to own both the customer facing services and the integrations between applications. Previously, the consumption-based model for Logic Apps wasn't a viable option for us due to some of the throughput limitations of managed connectors. The reason we decided upon Logic Apps Standard are the changes to the compute model, which remove these limits that have previously been a blocker for us. In particular here, the ability to bring your own infrastructure in premium app plans and take advantage of the firmly established app service ecosystem, such as public IPs, virtual networks, and private endpoints. With the introduction of stateless workflows and the ability to run the entire Logic application in process, this brought significant performance improvements and allowed us to quickly scale out the compute and perform a large amount of processing on batches of data. For this specific development, we only had a few integration patterns to consider. One example being batch ingest and enrich, where we consume data from an API and transform it into a canonical model, enriching it with ASOS-specific data as part of the processing and placing events onto Service Bus. Another pattern, a simple Service Bus triggered workflow, again performing enrichment and commanding other APIs to take actions using the enriched data. Logic Apps seem well equipped to handle both of these patterns, and this helped shape our technology choice. Beyond the capabilities of the integration technology itself, we also wanted an easy-to-use design time experience with familiar authoring tools such as VS Code and a rich local experience that would allow us to iterate on and test our workflows. Since Logic Apps Standard is built as an extension to Azure Functions, our engineering teams were well familiar with this compute model and the overall learning curve was low, allowing us to get up and running quickly and start building the integrations. Likewise, the extensibility model for built-in connectors means that we're able to author any connector we like using the familiar Azure SDKs, which opens up numerous possibilities. If a particular connector doesn't exist, we're able to author it ourselves and allow Logic Apps to perform the orchestration. From a DevOps perspective, using Azure pipelines, we're able to produce a build artifact for our provisioning and deployment process. Again, a familiar and solved problem to produce packages for deployment. The management APIs associated with the workflows allows us to execute with specific payloads and assert on the outcomes, giving us a fully automated process to create infrastructure, deploy workflows, and ensure they're doing what we expect them to. Operationally, the out-of-the-box application insights connectivity meant we're able to easily design observability dashboards and have automated monitoring of the applications through Azure Monitor alerts, giving us a solid logs and metrics story with little effort. From a security standpoint, our applications are associated with a virtual network subnet, which means we're able to take advantage of service endpoints and network restrict access to the various services we interact with, such as Cosmos DB and Service Bus. In future, we'd be looking to use managed identity with all built-in connectors, as we think that the combination of finely grained RBAC and network restrictions is a great security approach, removing the need to manage connection strings and having to perform any key rotations. In fact, in a number of our integrations, to perform the enrichment work, we had to consume ASOS APIs that are protected by Active Directory OpenID Connect. The built-in HTTP connector already has managed identity support, which meant it was an easy to implement bearer token security on our requests. Combined with simple declarative retry policies, we could focus on API contracts and the business requirements, knowing that the security and transient failure non-functionals are all taken care of. Overall, Logic Apps Standard gives us the ability to quickly build, host, and scale complex integrations within our infrastructure. Combined with a low learning curve and familiar tooling and engineer experience, This means we're able to build, test, deploy, and operate the solutions with a quick time to market, making Logic Apps a compelling choice for us. Looking forwards, we'd see a wider adoption of Logic Apps across our estate as the availability of both Microsoft provided or custom written built-in connectors allows us to take on more integration patterns, such as very large or high volume file movements. And we're also very interested in the different compute hosting models available, such as containerization and Arc-enabled Kubernetes, allowing us to run our integrations alongside our customer-facing APIs.
Awesome. I want to thank Dylan for sharing the story from ASOS on their journey of building on Azure integration services and looking forward for more amazing things to come. Now that we have learned the basics of Azure integration services and heard the customer story from ASOS, let's take a look at what's new and what's coming. For Logic Apps, we're announcing the public preview of SQL as a storage provider. With it, you can run Logic Apps anywhere and use SQL to store the runtime states rather than taking a dependency on Azure Storage. We'll have a deep dive later in the session on this topic. Next is Replication Task. It's another evolution of the automation task feature, offering you the streamlined experience to start replicating messages between and across Event Hub and Service Bus. HTTP timeout allows you to override the default request timeout, giving you more control. And we have improved the performance as well as the canvas and line rendering of our workflow designer. We are making CLI commands such as start, update, deploy Logic App operations available, and there is more. So make sure to check out our blog post on the fall release of Logic App to learn more about them via the link shown on the screen. As for what's coming, we'll soon make available the experience in Azure Portal to upgrade from consumption to standard Logic App. Of course, we're always improving the runtime performance, and we'll be making available the support for AAD authentication for request trigger, support deployment slot, and more integration with API management. We'll also be adding more CLI commands for workflow and connections, and tailored GitHub Actions and Azure DevOps tasks to make implementing CI/CD pipeline even easier. Next, I will hand it over to Divya to talk about what's new and what's coming for our connector ecosystem.
Let's talk about what's new in connectors. Logic App Standard comes with a new connector model which leverages the Azure Functions Extensibility model to enable adding built-in connector implementations like Azure Function Extensions. These built-in connectors are hosted in the same process as the Logic Apps runtime, and it provides higher throughput, low latency, and local connectivity. We are rapidly building connectors that are used in high throughput workloads in local scenarios using this model. And here are some that will be released at Ignite. In the category of file transfer protocols, we are adding support for SFTP, which is used for secure file transfer. We will be releasing the triggers to get file metadata or file content, as well as action to get file content in the first release. More actions are going to come soon. We have released built-in support for XML and liquid processing. We are now adding flat file encoder decoder to allow processing of flat files based on schema. We've also decoupled this from integration account, so the schema lives in your project and doesn't need integration account. Along with cost benefits, by removing integration account dependency, we also do not make network calls and are able to cache the compiled schema for even better performance. Another big improvement is with Cosmos DB connector, built by our partner Cosmos team, with not just improved performance, but a lot more capabilities. This connector now supports trigger, so you can receive documents from Cosmos DB. Along with the support for all the actions for CRUD operations, it now supports sending documents in bulk. Very excited to release these popular asks from the connectors. Another big area of focus for us is to enable support for managed identities for connectors for both consumption and standards queue. We have now added the support for MSI for multi-auth connectors like SQL, Azure Blob. We are also releasing support for MSI for all Azure connectors in standard Logic Apps. Later in this session, I'll be showing a quick demo on how to use MSI with connectors. And last but not the least, we have added support for peak lock in the built-in service bus connector, which now gives you more control on the processing of received messages. Now let's talk about what's coming in the connector space. We are working on a number of connectors and our goal is to get them into the hands of customers as soon as possible. This is why we are releasing these in increments and doing private previews to get your early feedback. To enable MSI, the connector needs to support AD authentication. For the Azure services connectors like Service Bus and Event Hub, we plan to add AD support and then MSI later this year. In standard Logic Apps, today we only support system-assigned managed identity. We will be adding the support for user-assigned identities very soon. Again, today in standard Logic Apps, for XML transform, we support maps based on XSLT 1.0. We will be adding the support for XSLT 2.0, 3.0, as well as ability to reference custom code. This will be available in private preview later this year. We'll be sharing the sign-up information for in our monthly webcast as well as on Twitter. Swift, which is a messaging standard for financial transactions, will be available in private preview on standard Logic Apps. This preview would include the support for Swift encode and decode to process the empty messages. We plan to add support for more protocol-based connectors, which can then be used to integrate with multiple applications. ODBC is the first one in this category, and we plan to release the first increment later this year. For SQL connector, we are working to add the support for more actions to support CRUD operations on SQL.
For API management, native support for WebSocket APIs have reached general availability. This support allows you to manage, protect, observe, and expose your WebSocket APIs in API management, alongside REST and SOAP APIs. The Event Grid integration have also reached general availability, which allows you to configure API management to publish events to Event Grid. Shipping to preview is the support for GraphQL APIs. Just like WebSocket, this feature allows you to manage, protect, observe, and expose your GraphQL APIs in API management. So make sure to give that a try. All right, next, let's take a look at some demos and deep dives. I will first hand it over to Beck to talk about the SQL Storage Provider.
Thanks, Derek, and hello everyone. I'm super excited to be announcing the public preview of our new SQL Storage Provider for Logic Apps Standard. Now, for those of you who don't know, storage is a key component of the Logic Apps service. Previously, with Logic Apps consumption, in a multi-tenant environment, storage was abstracted away from you. So this is something you've never really had to think about before. However, with Logic Apps Standard operating in more of a single tenant environment, we give you the keys to the kingdom so that you have more control and ownership of the storage of all the state and artifacts that your Logic Apps will generate. So this storage is stored in an external data store, and this just means if something happens to your Logic App during execution, the engine can go back and get its state from that external data store and pick up right where it left off, thus making it a stateful and resilient service. So, with Logic Apps Standard, you can now create a Logic App from anywhere, even outside of Azure. For example, in a local development environment, on premises, on multi-cloud, on AKS, all thanks to the new Azure Arc capabilities in public preview. So, the SQL Storage Provider is a portable and alternative storage provider to Azure Storage for when you're running Logic Apps everywhere. And we are very pleased to be announcing public preview of this capability here at Ignite. So without further ado, let's jump into a demo. So here I am in the Azure portal and I want to create a new Logic App resource. So I filled in a majority of my basics as usual. And in this case, rather than deploying to Azure, I want to deploy to my custom location. Now this is running in a Kubernetes cluster off of Azure, which I control. So now I can go ahead and choose which type of storage I want. I can choose between Azure Storage or SQL. Now, if I'm using an AKS cluster, which is also running on Azure, I could absolutely continue to use Azure Storage as the default. However, this is an off Azure cluster, and I don't want to constantly communicate back and forth with the cloud. So I'm going to use SQL instead, and I'm going to paste in my connection string to a SQL database, which is close to my Kubernetes cluster. So I can go ahead and paste that in. Now, today, the portal won't validate this connection string. And if you don't want to paste it in as plain text, you can absolutely put this behind a key vault reference, as this will eventually be stored in your app settings. Now I'm going to skip right to the end and I'm going to go ahead and click create. So while that goes ahead and deploys, I'm going to go ahead and switch over to my VS Code environment so we can look at how we can set this up locally. So here I have a new project in VS Code, and to configure SQL as my local storage provider, all I need to do is right click on my project and select use SQL storage for your Logic App project. This will then prompt you to paste in your connection string, and since I'm developing locally, I'm just going to plug in my local SQL Express connection string, as you can see here. So there you go, that's going to update my project settings to use SQL as my main storage provider. So if I go and have a look in my local settings, I'm going to see this is now using my local SQL Express instance as my storage provider, rather than actually using my local Azurite emulator storage that I might be using for local development. So now I can go back to my designer, continue working, I can go ahead and run this project locally, and it's all going to be posting things into SQL rather than my local storage. And it's as simple as that. That's all you need to do to configure SQL as your storage provider. All you have to do is update this particular app setting within your Logic app, point it to your SQL Server of choice. Of course, if you're deploying this in Azure, you can have this facaded behind Key Vault. And to show you everything working as expected, here I am in my SQL Server Management Studio. I'm going to go into the SQL Server that we configured for our Arc-enabled Logic app. I'm going to drill into my database, which I popped it into. And there you go. Now you don't have to worry about these names here. You don't even have to do anything in your SQL Server. This is just allowing you to be portable with where that state is kept. The closer you keep it to your Logic apps, the faster and more performant your Logic apps will be. So try it out today, and we look forward to hearing your feedback. Okay, so hopefully I've got you excited about the SQL Storage Provider for Logic apps. Now I'm going to move on to something that has been highly requested and is coming very soon. Now, we've all seen the awesome capabilities of the new standard SKU, and you might be asking, well, hey, how do I move my consumption Logic apps to this new SKU? Well, we're about to launch an out-of-the-box portal-based export experience to help take all the good work you've done in building your consumption Logic apps and moving that across to the new standard SKU. So without further ado, let's dive in and showcase what you can look forward to with this new export experience. So here we are in my consumption Logic app. It's pretty simple. It just takes a batch of orders, loops through them, and then sorts them by the quantity of the order to either accept them or reject them. Now I want to move this to standard, as I want to start developing this locally. So all we need to do is jump back to the overview page, hit the export button, and select export to standard Logic app. Now, this isn't a complete migration in that your old resource will still be here if you do the export. It doesn't override anything. It just takes what you have here in consumption and puts it onto a new standard resource. This means you can keep all your old run history if you need and do the full migration when you're confident that you've tested everything in the new platform. This gives you more control and the ability to fall back to your old Logic app if you need. So here I've opted to create a new standard resource. This might be the first time I'm doing an export of any kind. However, if I've done this export before, I might choose to use a pre-existing standard resource I've already created. For now, I'm going to reuse a workflow standard plan. I'm going to create a new storage account and a new standard resource. Once I've confirmed that, it's going to take me to the validation page, and this is going to tell me if my consumption Logic app is able to be exported, because as of today, there isn't a one-to-one mapping and there are some incompatibilities, but there'll be remediation steps to let you know what you need to do. Once you've confirmed that, this will take you to the confirmation page. You can either download the template to do this all locally, or you can hit export and get the portal to go ahead and deploy those resources for you. So this will then take you to the deployment page. And as we just configured, this is going to create me a new standard Logic app, a new storage account, and it's going to reuse that existing workflow standard plan so I can pack it full of all of my different Logic apps. So once that's gone ahead and deployed, I can now go to my new resource group to go check out my new resource. So as you can see, all those resources that I configured during the export experience are all here. All of my new connectors, my new standard Logic app, and my storage account. So let's drill in to see what my new standard resource looks like. Okay, so this is going to take me to my standard Logic app. I can now have a look at that workflow that it exported from my consumption Logic app. It's now going to show up as a workflow within the Logic app, and you can have multiple of these Logic apps here within the one resource. So if we go ahead and drill into that and open it up in Designer, you'll be able to see the exact same flow that we had in our consumption Logic app, but now this is all taking advantage of that new Designer experience and all the new built-in actions and all that goodness. So that's it. The export experience helps you get from your consumption Logic app into standard. This is an optional export experience. You can absolutely continue to use consumption that you know and love today. This is just an option if you want to take advantage of the VNet connectivity of standard, or you want to develop this locally, or all of the above that we've been talking about the standard SKU. So hope you're as excited about this as we are, and we can't wait to make this available for you to use. All right, back to you guys.
Before I jump into the demo on how you can use managed identity with Logic Apps to authenticate to different services, just quickly want to touch upon managed identity feature itself. Managed identity provides an identity for applications to use when connecting to resources that support Azure Active Directory authentication. And these can be first-party Azure services or any services that support AAD. And unlike other modes of authentication, where the onus is on the developer to securely encrypt, store, and manage credentials, all of that goes away with managed identity. So you do not have any management overhead. You do not, in fact, have access to the credentials. And of course, there are no additional costs associated with it. In terms of support, there are two types of managed identities available and are also supported in Logic Apps. The first one is system assigned identity, which is created in Azure Active Directory and is tied to the lifecycle of that service instance. So for example, if you create a Logic app and you enable system identity, the lifecycle of that identity is tightly coupled with the lifecycle of the Logic app instance itself. By design, the Azure resource can use this identity to request tokens from Azure Active Directory. Now, these should be considered when you want to associate independent identities per Logic app, or you want to manage identities within the scope of Logic app boundaries. The second option is user-assigned identities, which are created as a standalone Azure resource, and you can assign them to one or more instances of an Azure service. So for example, you could have one user-assigned identity and you can associate that to one or more applications, one or more Logic apps. Therefore, these should be considered when you want to access multiple Azure resources with the same identity, or where you want to share the identities across your applications, across your Logic apps. All right, so let's get started with our demo. What I have in front of me is the Logic app that I'm going to use to connect to Azure Storage using managed identity. Before we do that, we need to complete certain prerequisites. The first one is to create a user identity or a system identity and associate it with this Logic app. So to do that, you would go into the identity under settings, and in order to enable system assigned identity, all you need to do is change the status here to on, and this will auto generate an identity that will be tied to the specific instance of this logic app. So system identity is closely tied to the logic app instance. The lifecycle and the management of identity is completely coupled with this instance of logic app. The other option is to use a user assigned identity, in which case you create a user assigned identity, which is a standalone resource, and then you add it to your logic app. So that's what I have done it here, where I have already had a user assigned identity, and I have associated that identity to my logic app. And now I'm going to use this identity to access to my target resources. But to be able to use this identity to access to my target resource, I need to complete another step, which is to provide this identity sufficient permissions as well as access to the target resource. This is my Azure storage instance, and I have given reader access to my MSI, to my user assigned identity in the logic app. And with this, the logic app and the user assigned identity now have permissions to read data from the blob storage. Now, depending on the kind of application, kind of resources you are targeting, you may have to select the appropriate role, the appropriate scope, the appropriate set of permissions. For example, in case of SQL, you may have to give permissions at SQL Server as well as database level, and again the role that you choose may be specific to SQL. With that, let's move back to our logic app, and now we are going to edit the logic app so that we can use Azure Storage Connector here with managed identity. Alright, so I'm going to choose Azure Blob Storage Connector here, and we'll use the list blobs operation. Before I can use any step here, I need to create the connection. For the connection creation, we are prompted with multiple authentication options here. Naturally, for this demo, we will be using managed identity, and we need to provide a name for the connection here. Once the connection creation is complete, you will see the action card, and you will see an additional option here which indicates the managed identity that is being used in your action. Today we only support a single identity associated with a logic app, but in future we plan to support multiple identities, and when that happens, you will have the flexibility to choose any identity from your action card here. Now that the identity association is complete, I am going to provide the storage account information that we want to access here. Let's choose the folder. Now when we run this logic app, the access to your blob is now happening using managed identity, because that's what we used to create the connection, and it was successful, and we were able to retrieve the contents of the blob and list them. So that's all for the demo here. What I have shown you here is blob connector, but managed identity support is now available for most of the connectors to Azure services. So yeah, please do try it out and give us your feedback. Thank you.
Thanks. Hello, everyone, and welcome to Ignite. I'm Parth, a PM with Logic Apps, and today I'm excited to announce the public preview for Replication Tasks. This will help you as a messaging customer who's using Service Bus and Event Hubs to create tasks which will replicate messages in real time from Service Bus queue to queue, or to Event Hub instances, or to topics without writing a single piece of code and still being within the namespace resource. So let me talk a little more about what Task does, and then move towards the replication templates that will be added today at Ignite. So Task is a portal TOC feature that helps Azure resource users automate against their resources through a 3-step template-based experience. So if a user, for example, wants to purge data older than a specific age in their storage account, they can simply go to their storage account and set up a task by selecting a template. This experience makes it super simple and fast, so customers do not need to worry about simple automation needs on resources and only worry about business critical workloads. One thing to note here is until now, these task templates, which you're about to see in the demo, were only powered by consumption logic apps, which you can only view and edit once the task was created. We already had about 5 templates, but today at Ignite, we're releasing 8 more catering to message replication and also enabling tasks to be powered by Logic App standard workflows alongside Logic App consumption. To ensure that your messaging data is not lost in case of outages or unpredictable events in this world today, which can affect the namespace, we came up with 8 replication scenarios across event hubs and service bus. Let's take a quick look at what these templates are and jump straight into what this would look like into the portal. So as you can see on the resources of namespaces, you can enable instance to instance or to queue or queue to topic replication. So let's go ahead and jump into the demo now. Now that I'm in my portal and on my namespace resource, if I want to set up a replication task, I would essentially navigate to the automation tasks TOC and go about adding the task here. Now we have 4 templates here on the namespace resource, 3 out of which are for replication purposes, replicate to a service bus queue or to a topic from an event hub instance within this namespace. Let's go ahead and replicate to an event hub and select that template. Now that we've selected the replication template, just let's go ahead and simply connect to the target event hub. You can see the source is already connected. That is because we are accessing the task from within the source. So we do not quite need to connect. It's dynamically connected for us. Here we need to simply connect to the target by providing a display name and the namespace you want to connect to. You can also connect via connection string, which will enable you to replicate data to namespaces that are outside this subscription. But for me, it's within the subscription, so I'll simply connect and go to the configure where I can name my task and provide the essentials. Here I am going to name it as destination. The naming convention can also be found in the documentation, so please go ahead and give it a look. And this task will essentially be stored within this Logic App standard. If you do not quite have a Logic App standard, you can simply create new from this experience, and it will also create the other dependencies that will be required to power the Logic App standard in this experience itself. So let's go ahead and go to the next step. In this step, as you can see, simply we are going to be reusing this Logic App standard, and this will essentially create this task, which is a workflow within this Logic App standard. Now let's go ahead and check this task out into the Logic App view so that we can see the triggers, actions, and the run history and test this task out. And what powers this task, right? This essentially is a stateless Logic App standard workflow with a trigger and an action, simply put. Now, given that this is stateless, for us to test this, we would have to enable the debug mode, which is already enabled here. I'm just going to give it a couple of refreshes to make sure that it is up to date, and then pass in the events in the source. So let's go ahead and go back to my list view of workflows where I've created a sender workflow, which will send some events to the source. And let's run this by just passing in some payload, and this payload should be expected to also be replicated to the destination as it arrives in the source. So I'm just going to say source payload hello and run this. I am going to go and check my replication task workflow over here and the run history, and there you go. I've gotten a successful run. I can check the inputs and the outputs of the task over here and make sure that it behaves as we want it to. You can also leverage every single thing that you can with Logic App Standard in automation tasks as well. Thank you so much for attending this session. We look forward to hearing about your feedback and your experience with this particular feature. Please feel free to share this at aka.ms replication tasks feedback. Thank you.
All right, we're at the end of the hour. I want to thank you for tuning in and learning more about Azure Integration Services. If you haven't tried it out, go to Azure portal and try out the services and see what you can make. If you are an experienced user, check out the new features and we'd appreciate your feedback. Of course, please stay in touch. You can find us on Twitter, YouTube, and as always, we're available via email if you need to reach out to us directly. Thank you for watching and have a nice day.